my God. Invading Amplituhedrons from quantum space-time. Alien invaders from our human brains. So it will take some background on what we believe we know about the reality we live in before we can appreciate how cool Amplituhedrons might be. Background. The standard model in physics and general relativity taken together describe most all particle wave interactions, including electromagnetism that we have observed and measured, and most all gravity phenomenon and their interactions with electromagnetism that we have also observed and measured. Together, these two great theories constitute our accepted factual understanding of reality. But it turns out that even though we believe these can account for all the phenomena that we directly experience in our lives, that does not mean that we can actually predict reality with them through the math we have, which constitutes the standard model of particle physics or general relativity for gravitation. We cannot, and we have known this for 100 years. Quantum mechanics applied to the standard model says that all particles are actually both particles and waves, where the waves are waves of probability. So we cannot, even in principle, know, for example, both the location and velocity of a given standard model particle, such as an electron or a photon, through any measurement, because the wave-like aspect of their reality is actually just a probability wave describing the measurements we can possibly predict. In general relativity, we have the three-body problem, which says that if you have more than three bodies, and often just three or more, the gravity computations for how the bodies move with respect to each other cannot be computed in practice with the computing machines and the math techniques we know about. Yet, if you have only two bodies interacting gravitationally, we can with great precision tell you exactly how they will move in space-time. Often this is enough because the two bodies are so massive, or one is so massive with respect to the other, that the influence of gravity by any of the others is so small it can be ignored. In some cases, though, we must consider three bodies or more, and in those we can only estimate with some estimated probability how gravity influences all three or more bodies. Again, our math just gives estimates of what we can measure, not exact values for all that we may want to measure. This has caused physics to explore different mathematical frameworks created wholly out of human imagination, and not based on empirical observation for simplifying the modeling computations, which may also, as a bonus, join the standard model computations with the general relativity computations. Some of these imaginary frameworks are known as grand unifications, such as recently, for example, string theory. In recent years, interest in string theory has waned because it does not have evidence to support some of its unique predictions. Similarly, there is no accepted quantum theory of gravity that can join both general relativity and the standard model with a new particle similar to a photon in electromagnetism called a graviton. There are in fact many purely mathematical frameworks that physicists use to simplify modeling. And even if we can find a single framework with new predictions that can be verified, we still have the problem of not describing two phenomena that we can observe. The expansion of space-time itself through what we call, but know nothing about, called dark energy or gravitational effects that we can observe but not identify the mass causing it, called dark matter. These two, dark energy and dark matter, account for about 96% of all the measurements we even could make of the reality we think we know. So even if we got exact solutions for wave functions or the three-body problem, we would still only know about 4% of what we can observe in all the observable measurements we can make of reality. So, here comes some new math. This might come to the rescue, it might not. Amplituhedron Wikipedia. In mathematics and theoretical physics, especially twistor string theory, an amplituhedron is a geometric structure. and.wikipedia.org. Amplituhedron math has been known for a number of years as a possible grand unification that may also predict dark energy and possibly dark matter that we can observe. But more important, it may also enable simplifications of getting approximations of solutions for the standard model for sure, and perhaps general relativity. It does this by taking the hugely long and difficult equations for existing standard model computations and simplifying them into simpler equations. The question is whether this simplification actually is a theory of reality or not. Sabina Hossenfelder, a famous physicist in this YouTube, thinks maybe we now have evidence that maybe amplituhedron imaginings known to simplify math may also describe reality and thus give us some new fundamental physics. I think that physicists just make the best liars, and all their theories are just theories out of human imagination. Even mathematics, as Descartes wrote, is just a way to make up analogies about reality. We do not actually know anything for certain about how reality actually works. We just have very accurate guesses sometimes. But we should value our theories, even our theories out of pure mathematics, because they are fun to think about and may lead to a deeper understanding of the reality we can agree we can measure, even if we cannot predict some of the measurements we can actually make. The math is just too hard to compute. Maybe or maybe not. We can find a theory that accurately and computably always works for everything. Physicists are the best liars, the pinnacle of humankind. Medium.com.yet. The human brain seems to be able to do this, but just not with the accuracy that we would like or need to have. Many times in the reality we try to live with. Here is how your human brain computes, and you don't need much math at all to understand it. Consciousness figured out. It's confirming you are doing something. Medium.com.